just started editing the next video and I'm getting completely confused as to what I've done, where I'm at. I've added other videos in between and all sorts, so I thought I'd just remind myself and you what we're doing. What we're doing is we've finished staining and varnishing the enclosure. I've fixed her neck into place, and her neck now swivels nicely on the Lazy Susan bearing underneath. I've got this together, the machine that's going to animate her head, with the lovely sprayed steel coloured vertical bits and pieces. I think that's part of this video actually. This is working. You lift it up and it drops back down, and this video starts at the point where I'm using this porcelain handle or knob that I found in a drawer. I'm using this brass valve casting, and what I'm now doing is turning down this little spindle piece to connect the porcelain handle to this bit that slides up and down on the lathe. Thank you very much. So here's a piece of copper pipe, and then we can just put that on, that on, and they stack together, and that look really nice just coming out of the enclosure. So the next thing I need to think about is a latch of some sort, so that you can lift this up and something will latch it in place, which can then be released electronically and let it allow it to drop back down. I started off by thinking about, suddenly remembering I had a 3D printer, so I could have something, let's zoom in a little bit, could have something from the side that looks like this. If this is the copper pipe, there's a little catch, and as you raise this up the pipe, it just pushes the catch in and then flips it out and holds this up in the air, and then you could release it with a string. And I could 3D print that. Possibly it could end up looking a bit more like this, the piece, an insert that was 3D printed to hold the copper there and there, to hold the mechanism in place. Started thinking about different forms that the latch could take, and then thought about ball bearings. And ball bearings, I can't remember where I've seen it, but I've seen some sort of fitting or clamp or locking device where you have a row of ball bearings that poke out just a little bit in a circle around some sort of tube. Once it's clicked in, the ball bearings roll out and lock it into place, and then somehow they're allowed to roll down inside or to allow the thing to drop. So I'm currently thinking about working on that. Also, it looks rather like a face as well, which is strange. Now, the only sort of ball bearings I've got with any sort of reasonable size are these ones. This is one of those lovely smooth drawer openers. So I think I'm going to have to cannibalise this. I've had it sitting around for years, and as you can see, there's a row of ball bearings here which look like they could be about the right size, because all this stuff has got to, all this mechanism's got to fit inside a 15mm piece of tube. There's not a lot of room, so I'm going to take this to pieces now. There really is something fascinating about polished steel balls, or ball bearings to use the incorrect name. Just the way they move and line up. Very strange. Well, we have a pipe. So we've got the pipe like that, copper pipe, 15mm. We want the balls to somehow be here. They don't have to stick out very much, because the brass fitting is really quite tight on there. Slippery enough to slide up and down, but not much room here, so they just need to stick out a little bit, enough, but not too much. The holes doesn't want to be too big so they actually fall out. So we need to carefully calculate the diameter of the hole and the pipe so it just sits in, and then I'll need to do some experiments, possibly with the 3D printer, to work out whether I lift, whether the balls can slide down something inside when they're not required and then get lifted by something. I don't know, if you pulled that up, oh, it's a face again. When you pull that up, it could then pull the balls out. I'm not sure, I just need to experiment. It might be that they are free to naturally push in as you pull up something, and then you have to hold them down or hold them out to stop them from releasing. So the next part of the experiment is to get a bit of copper pipe and drill 3 or 4 or 2 or something holes around the circumference. Yes. By the way, I thought it was worth mentioning this tool. It's one of my favourites because it turns a really unpleasant job into a really fun one, and that's fantastic. Any tool that does that. So for example, here's the end of a piece of copper pipe I've cut off, and it's all burred over, and you can use a file, a circular file, to file that off, or some sort of reamer to ream it, or you use one of these. I can keep it in focus. All you do, which is so easy and enjoyable and fun, is you just twist this blade round inside whatever you want to deburr, and it does it. It's amazing. Such a lovely tool. And it also means, because of the shape of the deburring blade, you can deburr the outside of a hole, but equally you can poke it in, and by angling it slightly you can actually deburr the inside. Put a slight chamfer on it, which is ideal for this job. What a lovely tool, a deburring tool. I can recommend them wholeheartedly. So that's pretty good going. Now I need to work out, I think I need to print something now to hold the 4 balls in place and see how they work. Whether I can push them in, or whether they need lifting up or releasing or whatever. So we've got the finished 3D printed ball guide, if you like. Let's see what happens if I drop a ball down it. Well, it'll come out one side. Well, yeah, I assume it's because it's... There we are. Brilliant. Now let's go. These 2 bottom holes have got a 5-degree angle on, so raising up towards the centre at 5 degrees. I'm hoping that'll be enough to keep the balls rolled down to the bottom. So here's the copper pipe. Is this, let's see if we can, after some more fettling and fiddling and lining holes up, I've got the ball now to roll down. If I hold it vertically, I think it rolls back off the inside of the copper, but holding it like that and then sliding this down, it just pushes it out of the way. Whereas if we have that ready to slide up and I put a screwdriver in to hold that ball out, there you go, that's not going to ride up unless I let the screwdriver out, then it does. So I think we've got a sort of a prototype, and we've got an idea that obviously needs more work. I don't know whether I'm going to need bigger balls, because these balls are really, you know, they do fit and they don't fall out, but I think it might be easier to use slightly larger ones. Now I don't have a dividing head, and I needed a way of getting 3 holes accurately drilled around the outside of a piece of 15mm copper pipe. But I realised that my chuck is a 3-jaw chuck, so using all the wrong tools, I thought I'd go about doing this. I'll try and stop my hand getting in the way. I'm putting the piece of copper in the chuck, like so. I didn't have to do any complicated calculations because using the wrong tool, this is a parting off tool, what I can do, because there's 3 jaws on the chuck, turn it round till it hits the toolbar, or the parting off tool, slide that over and then just touch it onto the surface and scribe a line. 3 scribed marks 120 degrees apart. So that will not go past those 3 hardened steel balls. If I release pressure on this, then it does go past. You're actually making progress, moving in the right direction. I just can't believe how amazing the 3D printer is. Here's the completed printout of the last version, hopefully, of the catch for the on and off control, and it's just amazing. It's printed the hole for the little the ball bearings, or the stainless steel balls, hardened steel balls, get it right. The little slot to put in the brass pusher, if you like, that pushes the 3 steel balls out, just slides in perfectly. It's absolutely phenomenal, and this has been printed like that. So it started at the bottom and it's 85mm high, and it's perfectly symmetrical. I thought, no, there's no way that's going to fit down the end of a piece of copper pipe, and yet, single-handed, look at that. Isn't that amazing? The whole thing just pushes down perfectly. There's the reed switch that I've soldered and glued into place. The string is going to come out, and I'm going to have a servo motor mounted through a hole in the base. There comes a time in every man's life when he realises there isn't actually a machine tool to do a job, and then you have to resort to a really simple and effective old-fashioned tool that doesn't require electricity. I've got the servo fixed in, and I've painted it brass, so if you can see it through the front window it'll look okay. I'm just about to start assembling the bottom part of this. There's the 3D printed support for this brass pipe that I've managed to get a fairly good radius on, through which the cord, the nylon cord, is going to pull down. And that's going to fit inside here. So the string is, or the cord's going to come round through here and then off and through to the spigot, or whatever you call it, on the servo motor. I've put the ball pusher that's on the spring onto the nylon braided string, if you like, thread, and I've put a knot with a little spot of glue on to make sure it doesn't undo. I need a spring so that when this slides down it doesn't crash into the bottom. I've got some hardened steel spring wire, and the first thing you do before you... oh, I filmed the lens cap, what a faux pas. First thing you do before you make springs is you put safety goggles on, because very thin sprung wire has a tendency to whip around, hook your eyeballs out and throw them across the room. I was thinking, I need to get an 11mm diameter steel rod to wind the spring on. I haven't got one. Duh. Then I remembered I had a whole selection of different diameter steel rods in 0.5mm increments. Perfect. Here's the roll of hardened steel spring wire, or whatever you call it, I can't remember. and I've clamped one end in the lathe chuck over the 11mm drill bit. Now I'm going to make a spring. 3, 2, 1, test. Better, but still a real thud at the bottom. I think I need to try and find a spring made of far more rigid spring steel. Look at that, I'm very proud of this. I found a long length of brass wire and I've turned it round, because it's thicker, I turned it round a bigger drill bit and left the ends slightly more compressed, and then put it on the sanding machine, sanded them flat. Looks professional. 3, 2, 1. That's perfect. 3, 2, 1. That absorbs all the shock and everything else. It really doesn't matter how long this is. It looks nice. It looks fantastic. Originally I was thinking, oh, the spring shouldn't be too big, but why not? It doesn't matter. As long as this bit drops and the magnet on here gets out of range of the reed switch, it really doesn't matter. It looks really nice. And the fact it makes a huge amount of noise when it's finished doing whatever it's doing. I've got the control to switch Florence on and off finished at the side. It's got a lovely big brass spring at the bottom. You'll see why that's necessary in a minute. So if you want to know whether it's time for tea, you lift the handle up, Florence then tells you, and it switch falls down. Let's try that again. Slide the switch up, wait for Florence to tell you, and then the switch falls down. I've taken Florence's body apart, her mechanism down here, and rather optimistically made very few notes and hope I can put it all back together again once it's painted. I knew I was always going to have to take it apart because I hadn't painted any of the bits and pieces. So I'm going to paint her, and then while that's drying I'm going to put her head, I'm going to mount her head onto the final cabinet. So it's all slowly coming together. While the brass paint's drying, I've taken the spacers off, and which are ironically brass because I don't want them to be brass, I want them to be steel colour, silver, simply because that's what the original automaton was constructed, how it was constructed, and it looked beautiful. So I'm going to spray this brass silver and I'm going to spray that plastic brass, so it's all back to front. The handy little Hilda. Right, where's the silver paint gone? Here we are. I mustn't put it off anymore. I'm going to try and paint Florence's face. I just want to do the eyes and the lips, and that's it. At the moment I'll see what that looks like. I've managed to find some of these lovely old Humbrol paints that I remember using when I used to make plastic models. Really lovely little things. So, and some fairly unruined brushes, courtesy of the lovely children. I want Florence to have dark circles around her eyes, so I've got Florence's half-sister here, and I've been experimenting with graphite powder. I bought some ages ago for lubricating fine little machinery and machine parts without having to use oil. It's very, very slippery, graphite. It's very, very fine powder, so it acts as a really good lubricant. Now, I couldn't find any colour pencils or anything, so I thought I'd try that, and it doesn't look too bad at all. I fixed it by spraying it with clear plastic primer, which has continued giving a matte finish, but has fixed it into place. I'm pretty happy with that. So I think that's going to be the way forward. Also slightly metallic, which gives a nice effect. It's one of those problems that you could never imagine or predict. I painted Florence's sister's head with some of the Airfix Humbrol paint for lipstick yesterday, and it looked really nice. Left it, and the spirit in it, white spirit or whatever it is, slowly soaked around the her face along, see, there we are, along the tracks that the 3D printer had left. So capillary action just carried it along. I'm hoping it's on the surface, sort of between ridges, and hasn't actually gone within the plastic. I've tried cleaning it off with white spirit, but that hasn't really done anything. That's Florence's sister. Thankfully Florence, who's still upside down drying, wasn't nearly so bad. You can just see there's a slight little bit of red, which is annoying because I took so much care in painting it, and a slight bit of red that side. What I might have to do is use chalk or something to try and cover it over. It just seems a little bit of a shame. I'll see if I can find some other way of getting rid of it. Coincidentally, when I painted Florence's sister's eyes without any sort of rebate, exactly the thing happened. It bled around the side. In fact, you can see how far it's gone. It's virtually gone around to her ear. Thankfully, with Florence's eyes, I'd created little rebates in the 3D print, and that's brilliant because it's just helped to contain the paint and it hasn't run any further. Just got to add the black pupils now, but I'm so pleased about that. So I've got the errant pulley sitting on the laser cutter. You can just see where I've marked out the bit that needs to be cut out. I'm using the red pointer to hopefully line it up accurately. Let's just run through it, do the test. That looks okay. So shut the lid and see what it does. See if I can. It'll do it very quickly. Right, let's have a go. Let's start. I've put it on wood because I want to catch the laser if there's any sort of overrun or underrun. Good grief, that was nice and bright. Perhaps it's the effect of cutting through the paint as well. Right, let's have a look. Out of the way. And yeah, look at that. Perfect. That's going to be underneath anyway, so it doesn't matter. Hopefully that now fits. Let's go and have a look. That's worked out really nicely. You can see that the threads are now coming through enough to put the nuts on. And just here, if it will focus, there's a little gap between the bottom of the motor holder and the pulley. So that's brilliant. The pulley is now resting on the supports underneath, not resting on the motor housing or whatever you want to call it. Great stuff. Right.